Hello and welcome to Science for Class 9. Today's topic is matter in our surroundings. Everything in the universe is made up of matter. The air we breathe, the food we eat, stones, a particle of sand, everything is matter. As we look around us, we see a variety of things. These might be of different shapes, sizes, and textures. So what is matter? Matter is anything that has mass and occupies space. Matter is a collection of tiny particles. In this chapter, we shall learn about matter based on its physical properties. Since early times, man has been trying to understand his surroundings. Initially, scientists believed that matter was continuous. Modern day scientists, however, believe that matter is made up of particles and have evolved two types of classification of matter based on their physical and chemical nature. Let us discuss the physical nature of matter. Matter is made up of particles, and the particles of matter are very small. Let us start with the first property. Matter is made up of particles. How do we know that matter is made up of particles? Let us refer to a small activity. This activity is listed on the NCERT science textbook, which is also followed by the CBSE schools. Now in this activity, we take water in a beaker and we will mark the level of the water in the beaker. To this beaker, we add a spoonful of sugar. When the sugar is stirred in the beaker, we see that the particles of sugar get dissolved into the water. However, the level of water does not rise. Now this shows that the particles of salt or sugar get into the spaces between the particles of water. Now why did the level of water did not rise? Because the sugar cubes or the salt particles, which are made of smaller particles, got dissolved in the water. From this activity, we can say that matter is made up of small particles. So this brings us to another important question. How small are these particles of matter? For this, we will refer to activity 1.2, which is listed in the NCERT textbook. Now to do this activity, we will take 4 beakers of water which contain 100 ml of water. Now to the first beaker, we will add a few crystals of potassium permanganate. When we stir these crystals of potassium permanganate in the first beaker containing water, we will see that the solution gets colored. So first there was clear water in the beaker. After adding potassium permanganate, the solution got colored. Now from this beaker, we are going to take 10 ml of the colored solution and add it to beaker 2. Now we will see that the clear water which was present in the second beaker has got colored. Now every time we take 10 ml from the previous beaker to add it to the next beaker containing water, we will see that the clear water in the subsequent beakers gets colored. Now with every dilution, though the color becomes light, the color is still visible. This shows that there are millions of particles in just one particle of potassium permanganate. These particles keep on dividing themselves into smaller and smaller particles. So this proves that the particles of matter are very small. Let us discuss the characteristics of the particles of matter. Particles of matter are very tiny. Particles of matter have space between them. Particles of matter are continuously moving. Particles of matter attract each other. Let us look at the first property, the first characteristic. The particles of matter are very tiny. As we have seen in the previous activity, Just a few crystals of potassium permanganate could color the whole solution. Even on dilution, on repeated dilution, the color is still visible. That means these particles are so tiny that they can bring about a change in the color of the solution in which it is dissolved. Particles of matter have space between them. If you remember the previous activity that we spoke about, activity 1.1, when we added a spoonful of salt or sugar into a beaker containing water, the spoonful of salt or sugar got easily dissolved in the beaker, but the level of water did not rise. Now, why did this happen? Because the particles of salt or sugar got in between the particles of water. Now, the space between particles is minimum in solids, it is more in liquids, and maximum in gases. These are important points that we need to remember with respect to the space between particles. Like I stated before, the space between particles differs depending upon the kind of matter. So here we have solids, liquids, and gases. Now this figure is depicting the space between the particles in solids, liquids, and gases. Now in solids, the space between the particles is very less. The particles are tightly packed together in solids, while in liquids, the space between the particles is intermediate. So you can see the spaces, if you compare the spaces between the liquid and the solid, the spaces between liquids is more. Now look at gases. In gases, the space between the particles is the maximum. So this is what I meant by saying the space between the particles of matter differs upon the kind of matter. Now let us discuss the third characteristic of particles of matter. Particles of matter are continuously moving. To understand this, let us perform a very simple activity. Now we will take a glass of water. Now this glass of water needs to be left undisturbed. To this glass of water, we will add a drop of ink. When a drop of ink is added to the water, we notice that the ink gets intermixed in the water by itself. This shows that the particles of matter are continuously moving. And why are the particles of matter continuously moving? Particles of matter are continuously moving because they possess kinetic energy. They mix on their own with each other by getting into the spaces between the particles. Now, movement of particles is minimum in solids, it is more in liquids, and maximum in gases. The intermixing of particles of two different types of matter on their own is called diffusion. We observe that on heating, diffusion becomes faster. Why does this happen? Particles of matter possess kinetic energy. Now, on increasing the temperature, the kinetic energy increases and the particles tend to move faster. Let us discuss the next characteristic of particles of matter. Particles of matter attract each other. The particles of matter have forces of attraction acting between them. This force keeps the particles together. The strength of this force of attraction varies from one kind of matter to another. The force of attraction between particles is maximum in solids, intermediate in liquids, and negligible in gases. To understand this better, let us look at this figure which illustrates the particles of matter in solid, liquid, and in gases. It is important to pay attention to the space between the particles in a solid, in a liquid, and in gas. Now in solids, the particles of matter are very tightly packed together. That is, the space between the particles is minimum. Now, since they are very closely packed together, the reason why they are closely packed together is because the force of attraction between particles of matter in solids is the maximum. So this force of attraction holds the particles in a solid very close to each other. This does not allow the particles of matter to move freely. So the space between the particles of matter is the least. The movement between particles of matter in solids is the least, and the force of attraction in the particles of matter in solids is the maximum. Now let us take a look at the liquids. Now in liquids, the space between the particles of matter is intermediate as compared to solids and gases. Now since there is more space between the particles of matter, the matter can move about more freely as compared to the solids. And since the space between the particles is more than that in the solids, the force of attraction between the particles is less, and this allows the particles to move in a liquid. Now in gases, the space between the particles is the maximum. Now since the space is maximum, the force of attraction between the particles is negligible. So this allows free movement of the particles of gases. This brings us to the next subtopic, that is states of matter. Matter around us exists in three different states: solid, liquid, and gases. These states of matter arise due to variation in characteristics of particles of matter. Let us discuss each state in detail. Let us begin with the solid state. Since the space between particles of matter in solids is negligible, solids have a definite shape and they have a fixed volume. For example, let us take a table. A table has a definite shape and it has fixed volume. Its shape does not change by itself. The solids are rigid. It is difficult to change their shape. Of course, when force is applied to the solids might break, but it is very difficult to change their shape. The intermolecular space between the particles in solids is minimum. This is another reason why the solids are rigid. The force of attraction between the particles of matter is very strong. Now, since the force of attraction between the particles of matter is strong and the solids are rigid, solids are also the least compressible. The rate of diffusion in solids is the least. This is because the movement between particles in the solids is the least. Let us go to the next state, the liquid state. Liquids have no definite shape but have fixed volume. Now what does this mean? The liquids, they can take the shape of the container that they are put in. Now let us take, for example, water. If I pour water in a glass and I pour water in a bucket, the water is going to take the shape of the glass or the shape of the bucket. So they do not have definite shape, but they have fixed volume. The volume of the water does not change, but they do take the shape of the container, so they have no definite shape. Liquids are not rigid, they are fluid. The space between the particles of matter in liquids is intermediate. Now if you remember, we discussed in the previous slides that as compared to solids and gases, the spaces between the particles of the liquid is intermediate. This is the reason why it contributes to the fluidity of the liquid state. The force of attraction between particles of matter in liquids is intermediate, and the rate of diffusion of liquids is higher than that of solids. So this is another reason why the liquids are also more compressible than solids, because the space between the particles of the matter in liquids is more than that of the solids. Let's go to the next state, that's the gaseous state. Now the space between the particles in a gas is the maximum. Due to this, gases have no definite shape and no definite volume. They have no definite boundaries. What does this mean? This means that the gases can easily diffuse in the area around them. So the rate of diffusion is the highest in gases. It is more than in solids and liquids. The space between particles of gases is the maximum. The force of attraction between particles is minimum, and gases are easily compressed or the most compressible as compared to solids and liquids. Let us quickly go through a summary of the different states of matter. So here we have listed solid, liquid and gases. Solids have a definite shape. Liquids have no definite shape. They take the shape of the container. And gases have no definite shape. Solids have distinct boundaries. Liquids have no definite boundaries. Neither do gases. They do not have definite boundaries. Solids have a fixed volume. Liquids have a fixed volume and gases have no definite volume. Solids are the least compressible, liquids are more compressible than solids, and gases are highly compressible. The space between particles in solids is minimum. The space between particles in liquids is intermediate, and the space between particles in gases is maximum. Solids have the least rate of diffusion. Liquids have an intermediate rate of diffusion and gases have the maximum rate of diffusion. Solids are rigid and liquids are fluid. So in this class, we have learnt about the physical properties of matter, the characteristics of the particles of matter, and the states of matter. To support today's instruction, I will be sending some worksheets to you. If you have any queries regarding today's class, you may text me and with regard to whatever has been taught today, and then we will take it from there. Today now, where